This conference will now be recorded.
Yep. Welcome to the January and the first meeting for the 2021. Yep. Let's wait a couple of minutes for a few more people to join. I understand that some folks have conflict. But I've heard from Yuval of NVIDIA due to remove it out. He unable to join. It's only for one-off for this time because last week we wanted to get ready for some thermal discussion and we don't have it yet. So we moved it for 1 week. For those who stay in Austin, Texas, like myself, hope everyone is safe. I nearly got hit by a car on Monday because I was on the road and then Austin actually have a snow blizzard on Monday. And then while I stopped on time, so the car behind me couldn't stop on time and he had kind of veered off to the left. Good that he veered to the left and he didn't come directly onto me. We have like 3 to 4 inches of snow on one day.
Wow.
Yeah, that's quite a bit.
So here in the Pacific Northwest, we've seen nothing. It's been cold, but we've seen nothing.
Yeah, it's kind of fun for the kids.
Yeah.
Hey Damien, you're in Austin now? I thought you were in San Jose, the Bay Area.
Yes, actually I moved to Austin like a little more than a year ago.
Okay. Oh wow.
Yep. Still doing the same thing. Yeah, Facebook expand to Austin. I mean Facebook hardware engineering expand to Austin. So I took the opportunity to come over. Okay.
Nice.
Yep. And then yeah, I guess we have the quorum and let's start. Let me share my screen. Move it up. Hey, why couldn't move it up? Okay, great. So today there's two agenda. First is to provide a mechanical fit test picture update, and second one, I will say the meat of the discussion today is really on the top form factor thermal discussion and how we move forward. First of all, mechanical fit test picture update on behalf of Chris. So Facebook has completed design before Christmas, and we decided to build this small prototype in-house. So this will have a small CNC lab in-house, so we're going to build it there. So after the CNC is done, Chris intends to perform the fit check first himself, and before he shared with the mechanical community for feedback. And so far, I have seen Chris also engage the connector vendor to obtain the connectors for the to fit into the test fixture. Is there a timeline that the community needs the design files to be contributed? The reason I ask that is because the intent is we prototype it and then send it to a few key folks in the mechanical community for feedback, see whether good enough before we actually post the design file to Wiki to make sure that we have a higher quality contribution. Does that sound good to the folks here?
Hey Damien, a question. Is there like any sort of documentation outlining what features or mechanical features that this fixture would catch or trying to test?
It's not something that I'm aware of, but I think it is a good thing to do when we do the contribution together. What is intended to check. Since Chris is not online, maybe Jonathan, you can help to verbalize a few of that.
Yeah, so I think the purpose was essentially to help verify the mechanical fitness and basically trying to make a CTF requirement. So in the mechanical section, there's a CTF, there's critical dimension that need to be making sure that it fit properly. So that's what this does in a rough way, right? But you still need to perform the CTF measurement on those for your card for process capability and repeatability. But this is essentially if, let's say, a new system vendor takes a card, plugs it into here, and it goes in and locks everything in place, you can be at least 90% or so confident that they'll fit into the system.
So in terms of CTF, Jonathan, is it to validate all the CTF that's outlined or listed in the spec? And also, are you checking for just the main dimension, or does it also check for the tolerances?
I don't think this will be able to check all the tolerances down to the significant digit that we're looking for, but it help in regard to overall.
Okay, thank you. So Damien, can we? Is it possible? I know you're saying you're going to send it out to a few companies to try. Is it possible to sign up for this kind of fixture? Or request?
Yeah, it is possible to sign up to get early seeing.
Someone has
Yeah, can I
some
ask
background
everybody
noise.
else to mute the microphone?
Yep. And for those Yep, let me see what I can do that. For the not speaking, maybe we can mute.
Looks like it's Justin Long. Okay.
Okay. Yep.
Sorry, Damien, I missed the first part of what you said earlier. Can you repeat that?
Yep. Long. Yeah, I think it's possible to sign up. The intent is to provide to the mechanical community. So as I know, we built a few, and then if let's say there's more interest, I think we can rotate them also. Anyone else that would like to have a preview of this?
This connector is just for a test fixture, or it's a for the whole system.
This is for the NIC card actually. So this test fixture is for the NIC card to plug into the enclosure. Maybe I should bring it up. I shared it a couple of weeks ago, and I definitely should put in as here as well. Let me bring it up real quick. Okay, it's connecting. So it is a fit fixture that basically we can plug in the small form factor or large form factor cards like to the hole and see whether it fits. The top portion is actually click, as I understand, it is see-through. Yeah, so we can see whether they have any interference. Yeah, this side is for the large form factor.
So you need the connectors from back?
The connector at the back will be, as I know, fit in and glue.
OCP, right? Yeah.
Yeah, so you need the NIC card. Yeah, you need the NIC card to plug into the fixtures. So the unit under test is actually the NIC card.
Because the action item looks like you said Chris is looking for some connectors. If you're looking for the connectors of that NIC card connector, let him to contact me. I'm Junhua Chen.
Oh, Jinha. Yeah, Nick already. Yeah, sorry. I mean, Chris already.
Already got it.
Okay. Yeah.
Okay.
Yeah. Thanks, Jinha.
Yeah, this also works well. Let's say if you do an NPI on a new NIC card and you wanna, when you assemble everything, and you don't have the high-end measurement, you have caliper that you may not trust, you can take this your new card and plug it into this fixture to make sure that everything fits and within the limit before plugging into a system or send it out to a customer.
Okay, good point.
Hey, Jonathan, so is the goal of this at the end of the day is in the future, this is in addition to the actual, measurement at manufacturing, right? It's not to say that we're not gonna skip the, those measurements later. This is a rough. This is mainly for engineering purposes, right? It's not meant for production, where you say, "Hey, my card fits into this, so that means I pass all the tests," right? It's just for engineering purposes.
Correct. Yeah. So either engineering for NIC card, right? When you bring up, you assemble a new card, you want a quick check to make sure everything works before, because it takes time to send your card out to a third vendor or somebody with high precision measurement and do all that analysis. So in the interim, you can use this as a quick check. Also for a system supplier, you can have this, and when if you have multiple customer and they send card to you and you want to verify that it fit and you don't have the data, you can also use this to verify as well.
Okay.
Yeah, especially you might also get batches that why some could be harder to fit in or borderline like cannot be fit in, right? Then it is also something they can check against.
Yeah, as a NIC card for me, I think one thing that would be very helpful with this is, for example, like component placement and interfering fit limit from top and then the bottom, because those are challenging to make measurement on yourself unless you send it out to a CM supplier to make those accurate measurements.
So, Jonathan, does the material, I think is it aluminum or stainless steel material? Is it allow for example, when you put the card in and you clamp it in, it's kind of hard to know whether you're actually touching the top or the bottom. Is the surface allowing some sort of kind of dye material to be sprayed, on the top or bottom lid, so that when you open it up, you can see, hey, it's actually making contact to the top of the heatsink or a cap on the bottom, for example. Is that something?
I'm not sure what. I think Chris made this on the top side is a see-through, maybe plexiglass. And yeah, and then it's a slide in. So if you can't slide in, or if you're sliding in doing the sliding process, you're hitting something and it's hard to slide in, right? You know it before, because the intent is not the clamping, it's a sliding. It mimic exactly the way you insert into a system.
Right, but that would be a gross violation. But I'm just talking about like something that is really already on the borderline or barely touching. If the surface allow us to put some sort of spraying something, some paint or something on the top lid, then you can pretty much visualize, if the dye can show up on the heatsink or something, then you know that it's actually on the borderline. So it's give us a better idea of the margin that we have.
Yeah, I'm not sure. We may need to verify that, but I'm guessing right now with the way the fixture is everything will be that opening. Once you insert it inside, right? If it fit through that opening, that means it's going to fit through that profile inside.
Okay.
Yeah.
Yeah. I'm not sure whether your die has some special characteristic, but yeah, I think it's possible to spray something on this, and then you can fit in and see whether they get scratched. But I think the die capability was not mentioned when we first discussed about it. But I don't see a reason why we cannot spray something on the material.
Okay, we'll figure it out. Yeah. Thanks, Damien.
Yeah. The only one we talk about is the top has to be transparent, so we can see any potential interference, and yeah, how well it fits. Okay. Yeah. Oh, by the way, since we are in this picture, maybe I can talk that. Yeah, this is the added feature with the newest design that has the spring loader to check for the internal locking mechanism. Yeah, it was the feedback from the community, and Chris incorporated it.
So just push in, right? Push it in. Or pull out.
Actually, I'm not sure how it works.
I'm guessing
it looks like it can be pushed in and out, and there's this thing to screw it.
Okay.
Yeah, it looks like push in because that's how the spring was being attached, right? So I guess
okay.
it's push in. Yeah. Yeah, I have not seen the real one. Yeah, I think it's in the process of shipment.
Okay.
Okay. Yes. Okay. Next, we'd like to continue our discussion on the tall form factor. So initially, things that they are all are not changed is regarding how we stack the two tall form factor that we have in the 1OU. That's not changed. However, I think it's also good to show that if we were to have the NIC in like the open rack standard, like 1OU versus the standard 1RU. So 1RU is approximately 44.5 millimeter, and for 1OU is 48 millimeter. So with the slightly more height, then we actually able to put PCIe cam together with the 17.8 millimeter connector that we call tall form factor. And another one is we also can stack if there's any need, but I don't think there's any need to have these two, that 17.8 and 20.1 in the same chassis. But I think what I really want to point out is regarding if there is a need to have a 17.8 stacking with cam, maybe open standard, like maybe OpenRAC v3. It's pretty cool by itself in the future. Would be a good one. Yeah, just to bring up some mechanical awareness here. The next one is regarding the Thor form factor thermal discussion around the hot I/O. I sent out email to some system vendor asking for clarification on the hot I/O operating condition. Myself are not that familiar with hot I/O because from Facebook design we actually have cold I/O. The reason I asked is I have seen this chart that Thomas, we have it in our OCP next spec that kind of says that beyond 300 FM, even for hot I/O, is non-typical server airflow. I would like to double check this statement. Yeah, and do we have a system vendor online that also have system that uses when your NIC is plugged into the hot I/O? Would like to double check whether this is something that we actually do the boundary condition correct here. Any feedback to the hot I/O airflow capability for your systems? Okay, if not, I'll rely on email. I already sent an email. I will just ping the folks that I know that they have hot I/O system. I'll follow up through that. Yeah. Well, one thing I'll point out is 300 FM for hot I/O is very, very challenging. I believe there may be something special was done even with our existing 15.1 millimeter NIC card that allow hot I/O operation. Okay, if now I pass it to Michal and Anna from NVIDIA to talk about their findings regarding the torsion factor and the extra torsion small factor, and also Lenovo Warren requested to check 85-degree optics. That's something that NVIDIA team has done as well. Michal and Anna, do you want to share, or we can use this screen?
And Damon, we can continue with this screen. It's okay, I think.
Okay, great.
Okay, do you hear me well?
Yes.
Okay. In general, this slide remains the same as it was a month ago, except there was an access title with inlet ambient temperature that we changed. And the main purpose of this slide is to show that for current or previous project, it will have benefits for higher form factor, and for higher form factor we have the better results, and you can see here that for extra tall form factor we have the best results, and for tall form factor better than our current form factor. This case study is about OCP3 project with 100 gigabit dual port. Chip power is about 20 watts, and QSFP power is 2.5 watt each. It's Mellanox NVIDIA cables. So in general, know that it can be up to 3.5 watt. And we also we checked here hot I/O direction, so we can see here that for small form factor, it's really difficult to pass for 55 degrees Celsius in the ambient temperature. And if you can insert some fins on the OSFP, so we can decrease our airflow requirements or increase in the ambient temperature that we can pass. Again, this slide was only checked that increasing the form factor is only have benefits for the current QSFP designs. Any questions?
Yes, there's one thing to point out, not really a question, is if you can see that this for hot IO application, if you assume 55 degrees C, the existing form factor are not in line. Like we cannot even have that operation, and we are talking about 500 to 1000 LFM. That's why I questioned in the previous slide that the 300 LFM is non-standard for hot IO. Is that true? That was the reason.
Yes, you're right. 300 LFM is almost impossible for cables to cool it. It's okay for a chip, I guess. So the limitation factor for all these curves is QSFP and not chip. And I run it from 5,000 LFM to from 500 LFM to 1,000 LFM because I saw that below 5,000 we have no chances to pass with cables. So I just didn't think that it's smarter to run below 500. And also there is no reason to run above 1,000 LFM because it's the upper limit in the chart of tiers for 55 degrees in the temperature in OCP3 spec, if you remember.
Yeah, you mean this is 45 to 65, right? Yeah, this one.
This is chart. This is some kind of graph, but also we have table with all tiers. And for 55 degrees, the highest tier is tier 12, I think, and it's about it's 1,000 LFM. So we don't have in the spec more than 1,000 LFM.
Yeah, but that sounds a lot. That's why I also double check with
Yes.
system vendor.
Yes.
Hey, and I have a question. So
Yeah.
you said this this data you're showing is address the QSFP thermal.
Yes.
Now, is there a study for what it looks like if you have the chip powers for different chip powers? I mean, right now you're fixing it at 20 watts, and do you have one that shows the airflow required for the chip power that's going beyond 20 watt?
But I didn't do it for this specific project because the most difficult part for us is cables in general, and I just took some project that we did in NVIDIA, and I just did some changes in the design of heatsinks. It is possible to check how it fluids with a higher ASIC power, but again, the most problem here is cables. It's our models.
I would like to add something.
Yeah.
It's Michal from NVIDIA. If the power of the chip will be higher, then more heat will go on the ports and the graph will seem even worse. So if this is the best of this specific project, these are the best curves. If you do with 30 watts or higher, it just will be worse.
Yeah, exactly. Thank you.
Yeah, I agree. I think I mean, it's we should have a plot that shows not just the they show both the chip power increase as well. I mean, The chip now, 20 watts can be low for high performance.
Yeah, I think the total small form factor and actual total small form factor will not only provide the benefits on the ports, but also provide the benefits on the chip cooling. So I think that's probably the reason, like if we can have a study on like what's total small form factor and actual total small form factor can provide the like an actual margin on the NIC power side, that will be an actual benefit.
Yeah, but I think what Anna and Michal trying to say is the limiting factor seems to be the first order is the pluggable. So the analysis is based on that, and chip power obviously if we go higher, form factor it does allow a taller heatsink that will help as well.
Yes.
Yeah, and I definitely understand that. Yin also shared your analysis in OCP Tech Week that you actually have the next ASIC power as well, information as well. But that is for cold IO.
Can we continue?
Yep, I think the meat is also in the next slide, whereby we also look at different optics.
Great. I think this slide is more relevant for our current discussion because here we're talking about our future generation, and our case study is 400 gigabit single port OCP 3 project with two types of cables. It's OSFP RHS and OSFP with integrated heatsink on it. Chip power here is much higher. It's up to 40 watts. It's around 40 watts. And OSFP power it's nearby 9 watts. Again, airflow direction is hot aisle. For this study, it is possible, and it can be right to see separately on OSFP temperature and ASIC temperature because they don't really influence one another. But again, if we're talking about the system, about the card itself, for most of the cases, the limitation factor is a module. And you can see here on this graphs that OSFP RHS with no heatsink at all that can suit tall form factor. It's really far away from the 55 degrees Celsius. But yes, we added here the theoretical cables with the limitation with 85 degrees Celsius. You can see here it's the dotted curves. One blue for OSFP RHS without heatsink, and one orange for OSFP RHS with heatsink for extra tall form factor. Now, this I need to say again, it's only theoretical cables. We in NVIDIA don't have these cables. I don't think that we will have, and I don't know when and if these cables will be available on the market. I don't really know. But again, here you can see that tall form factor is very, very hard to pass in for 55 degrees Celsius. For extra tall, we have both OSFP RHS with heatsink and OSFP with integrated heatsink that can work at 55 degrees Celsius. And OSFP with integrated heatsink is the best one. And I can say that, as I remembered, this is the same temperature, the same limitation we have here for OSFP and chip, so it's the most optimized system. I think I was clear enough. Do you have any questions?
I do have one question related
Yes.
to tall small form factor and OSFP RFS without heatsink. Is it no way we can attach a heatsink in this form factor?
We can add only just plates, some kind of flat heatsink on it. But again, it will be between the curve of RHS without any heatsink and with heatsink for extra tall form factor, and it doesn't pass at 55 degrees Celsius. But yes, it's better than just regular OSP RHS without any heatsink.
And if we have the QSFP-DD form factor, then we should be able to add some heatsink on the top of the cage under the tall small form factor range, right?
Again, yes, you're right. We can insert here QSFP-DD with small heatsink on it, but as we saw in our simulations, it will be worse than OSFP RHS with heatsink. That's for extra tall form factor, and it will be between. Again, it will be between OSFP RHS without any heatsink and OSFP RHS with the heatsink on it. So I think QSFP is also not good enough for this application, at least.
Yeah, I agree with your conclusion. So I think if we have the QSFP-DD data here, probably it's between the blue line and then the orange line, right? Or the dotted blue line. Yeah.
And I would like to add, hi, this is Jonathan from NVIDIA. I would like to add two more things. One is currently the OSFP is the only connector that supports 100 gig per lane. I know that QSFP and QSFP-DD maybe in the near future will support those rates, but at the moment they do not. And that's why we examined this connector here. And the second thing is that the OSFP that is not RHS, the regular OSFP, the thermal activity of it is the thermal performance is much better because the heatsink is part of the cable itself, and that fits only in the extra tall form factor. So that's another motivation why we are also interested in that height.
Yeah, I can understand from that perspective. Yeah. Yeah. However, like the extra tall break quite a lot of stuff. We also need to see whether that is the only option if we want to go there. And then I do see that the rider heatsink without heatsink is thermal performance is poor. Is almost expected because there's no rider heatsink. Some design actually put the heatsink at the side. Like there is more like a thin heat spreader, and then the heatsink is at the side. It is something that is we do that. We do that, and we're actually working on it. And maybe Michal can say some more, but heatsink, we do it as in addition to the heatsink on the top. If it's only on the side, it's less effective.
But I know it's possible, but we use it as part of, let's say, in the chem cards, we use it top plus sides. Okay.
Okay.
I don't know if Michal ever checked the benefit of only on the sides, but I'm quite sure it will be not as good.
Yeah. By physics is the further away from the heat source, this is not as good.
We do it in the OCP small form factor with regular QSFPs. Again, we cannot put fins on the top, so we use only fins on the sides.
Yeah, regular QSFP also cannot put fin on the top. So to put fins, we need QSFP DD and or OSFP RHS. Yeah. I don't think John is here. John Lewis is still join. Basically, I would like to double check with John Lewis initially that that when Dell came up with a proposal, and then there is a when we go for this height, which is basically now the tall form factor, there seems to be have ways to put OSFP IHS cage. I would like to double check in this assumption that shows the thermal performance that we can either increase inlet temperature or reduce the ASIC temp. Is there any assumption on the module heat sink? Is there anything that you could share with us if there's any? So that was, I'm thinking of ability to add heat sink or heat spreader on OSFP IHS, give a better viability that the top form factor or 17.8 millimeter to go through the feedback process that we're gonna start soon. That was
Hey, Damien?
one of it. Yes.
It does say in the third bullet that it's support the heatsink.
It's a QSFP with heatsink, but I'm not sure whether there's
the
OSFP
OSFP.
with heatsink. Yeah.
I see.
Because in NVIDIA analysis, you see that OSFP IHS cannot, at least not having a heatsink here. I wonder if there is a mechanical challenge that we unable to, or that's due to mechanical challenge is too great. Even we have it, it doesn't help much because maybe too thin. The heat shredder is too thin. It doesn't make sense. So that's the part that I would like to double check. If that is yeah.
What's the height difference between? Go ahead, sorry.
Yeah, just a little notice. You can have a heatsink on top of the OSFP RHS and PSFF.
So we can have.
Yeah.
Okay.
So what's the height difference between what's NVIDIA is proposing and what's Dell is proposing?
They align.
We are proposing the same. Yeah.
Yeah, they have aligned.
Oh, okay.
So there's so basically now we have three, right? So the top form factor is aligned from NVIDIA and Dell, and then the extra tall proposal from NVIDIA. But anyway, we shouldn't look at which company proposed what. We should look at the technical items. Yeah. So yeah, at this point we have two options on the table. Actually, three options on the table. Like, first option is do nothing, right? Keep just the existing form factor. And the second option is pick which one. Probably third option is do both. Hopefully we don't go there also.
Yeah, Damien, if you could zoom in this snapshot, you could see a heatsink on top of the PSFF.
This one? Yeah.
Yeah.
I
it's about 2 minutes.
I would like to double confirm with Andre. You mean for the OSFP IHS, you are able to put a heatsink in the tall small form factor?
Correct.
if that's the case, can we do one more simulation in the maybe next week, and we send out offline that we get this OSFP ISS in the 17.8 and with the heat sink and see how much it improved. Personally, after all the discussion we have, I felt that if we send out the survey for 17.8 millimeter, we have a higher chance of success. If we send out a survey for 20.1 millimeter, I felt that they could be more resistant. And we really need to make sure that it's 100% that we have no other way to go before we propose the 20.1 millimeter.
We will check it again, and if we can put the heatsink, we will simulate it and send you more results. We understood that we can put only a plate, but we will check it again with Andre, and if we're mistaken, we'll add the simulation.
But as we know, the OSP, the connector, the already include the heatsink in the connector and the cage. So no need to request additional heatsink outside the cage.
OSP, yes, but for OSP RHS, the one with the rider heatsink, it doesn't have the heatsink in the cage.
Yeah. If you look on the OSFP RHS, it is the same height as QSFP. And if we extended the height, that means that we can place the heatsink of about 2 millimeters above the cage.
Again, can you highlight again in the center of a picture, the picture, center of picture, what kind of a connector in here?
Actually, Andre have a pretty good one a couple months ago. Andre, you still have it handy? You want to do a quick share?
Yeah, just a second.
Yep, I'll try to find as well here.
Thank you.
Yep, I think while Andre is looking, so the thing is based on yin analysis on help to do analysis on the cold IO. So the 17.8 millimeter seems to be good enough for our use cases in the 400G frame. So why we are talking about the 20.1 millimeter are mainly for two reasons. One is the hot IO benefit. Second one is the ability to take OSFP plug.
This is John with HPE. I just had a quick question on the thermal simulations. Can you share what assumptions were made around the heatsink material, the TIM, and any other thermal interface details that would go into this simulation? Unless those were shared somewhere else and I missed it.
And Michal, can you take that question?
The heatsink is from aluminum. And are you talking about which TIM for the chip, the IC?
Yeah. Going into the ASIC on the chip, yeah.
I can check in the simulation and come back to you. But again, the main issue here is the module. This is the limiting factor. So I think it's a bit less relevant about the chip. But I can check what we added in the simulation and send it to you.
Okay, thanks.
Yeah, Damien, I hijack the screen. If you can see now, just let me know. Can you see my screen?
Yes, I can.
All right. So this is the most updated models which were shown on the Tech Week. Here we have a tall small form factor, which is 80.1, and this is OSFP RHS with heatsink. All right, so the maximum heatsink height is 14.5 millimeters, and this clearance is supposed to accommodate the tolerances and the travel of the heatsink during the cable insertion.
I want to check one thing. I think earlier, NVIDIA initial proposal is 18.1, and then Dell proposal is 17.8, and both of you align to 17.8. After align to 17.8, can we still put the heat spreader?
Oh, sorry, this is 17.8. I showed you the previous one. This is the proposal update. The 17.8, as you can see, this 0.3 millimeter was shaved from the heatsink height. So the heatsink is still existing, but it is 0.3 millimeter lower.
Okay, got it.
And I think that I can show it also in the next slides. And not here. Here it is. So this is a regular SFF, tall SFF with a heatsink. Quite a shallow heatsink, but it does exist. And this is the extra tall SFF with the full OCP.
Hi Andrew, can I ask like how I didn't catch up the how tall the heatsink can be on the tall small form factor for the OSFP?
You can see it here. Without a module in the cage, the top height of the heatsink could be 14.2. This dimension could be controlled by your manufacturing. If you tighten the tolerances on the heatsink itself, you can make it a little bit taller, but not significant.
Okay, so above the PCB, it's about 14.2 millimeter available.
Correct.
Okay.
Okay.
Right.
Yeah. Yeah. The intent is we get an updated result through email next week, and then we formulate the survey questions with the results shown, and then we send out it through the survey to the community and see whether we have good enough input for us to make a decision in the next month, the OCP NIC meeting, which one we'll focus or we can do anything. Hopefully we won't do anything, but my hope is we'll do something. Just which one.
Then can we have a meeting not within a month, but within 2 weeks or so?
Working session.
Because we are quite interesting to implement those additions and to vote to make a decision.
Do you mean that you would like to see a working session being set up so we have a chance to talk about this again in 2 weeks?
Yeah, it would be great to not to wait another month to the monthly session.
Yeah, I think the working session we definitely can set it up. It's just that whether the survey close, and then have the decision made in 2 weeks. That is a part we might not have it. I think a month is almost the right time for make that decision, but we should have a checkpoint in 2 weeks. Yeah, we can do that.
All right. Thank you.
Okay. Yeah.
So
And yeah, Mihao and Andre, please put together and see how high the heat spreader heat sink can be, and then yeah, share the result with us through email maybe next week.
can this presentation be posted?
Yes, all the presentation. Yes, all the presentation are posted in our wiki monthly. We should have it there. I will post this one, yeah, shortly.
Yeah, I just was trying to understand the differences between this one and the one from OCP Week.
Sure. Yeah, okay. That's more update.
Okay, thank you.
Mm-hmm. Okay. Yeah, I think we have the next step. Thanks for your time, and I will find a slot to schedule the working session. Probably an hour for this case, unless we get any other topics to discuss. Yeah, feel free to send me emails if you have anything else. Okay, great. So yeah, that's all for today. Thanks for your participation. Yeah, we're making progress here. Thank you. Bye. Take care.
Thanks, David. Bye.
Thank you.
Meeting adjourned.
Thanks, Damon.
Okay.
See you later. Thanks.
Bye-bye.